Hello guys, welcome back to the channel. Today we are going to solve this Leetcode question, which is flip equivalent binary trees. In this question we are given a binary tree and we can define a flip operation as follows. Choose any node and swap the left and right child subtrees. A binary tree of is flip equivalent to a binary tree y if and only if we can make x equals to y after some number of flip operations. Given that roots of two binary trees, root 1 and root 2, return true if the two trees are flip equivalent or false otherwise. So basically, what we are given is that we are basically given two trees, two binary trees, and in these two trees, one of the trees is either flipped or not. We don't know whether the other tree is flipped or not. What does it mean by flip? Flip means, suppose if we have these two trees, the children of the root node, not only the root node, it can be any node, the children of the node can be swapped. Suppose something like this. If we have 1, 2, 3, here we will be having 1, 3, 2. So basically, in one of the trees, the tree can be flipped or not. We don't know that. And there can be any number of flips in the second tree. Here there can be any number of flips. We cannot say that there can only be only one flip or two flips. There can be any number of flips, and we need to check if both of these trees are equal or not, if the flips are not performed. Let's say if the flips are not at all performed and the tree is as it is, then we need to say whether the both the trees are equal or not. So let's look at this example in order to get a clear idea. So in this initial example, we have this tree 1 and we have this tree 2. In this, we need to check whether both the trees are equal or not. Here if you see, 1 is equals to 1 and 2 is equals to 2 and 3 is equals to 3. So these two trees are equal. Let's look at these two. This is tree 1 and this is tree 2, right? So 1 is equals to 1, and here on the left subtree there is 2, but here there is 3. So can we say that these two are not equal? We cannot, because here the tree is flipped, the 2 is over here. So we need to check whether it is flip independent or not. I mean, what if the flip is not performed for this tree? It would be something like 1, 2 and 3. If the flip is not performed, it would be like this, right? So 1 is equals to 1 and 2 is equals to 2 and 3 is equals to 3. So these two are also equal. So this is the question. So we need to return true if the tree is flip equivalent or not. Otherwise, we need to return false. That's it. So let's try to break down the problem. When it comes to trees, it's really better for us to think think by breaking the problem into sub problems. Let's try to think when we have only one node. Let's say we have only one node in the tree. This is tree 1 and this is tree 2. Let's say we have these nodes. This is 1 and this is also 1. So are these trees flip equivalent or not? They are equivalent, right? Because 1 is equals to 1 and there are no other nodes which are not equal in both the trees, right? So it is flip equivalent. Let's go here. Let's say we have another set of nodes. This is tree 1 and this is tree 2. So are these flip equivalent or not? These aren't, right? Because no matter how many flips I do, I cannot make these two I cannot make these two trees equal, right? So this is not flip equivalent. Let's try to increase the number of nodes right now, slowly. Right now I have two nodes in both the trees. This is tree number 1 and this is tree number 2. Are these two trees equal or not? They are, right? One, and on the left we have 2. On this tree as well we have 1, and on the left we have 2. So these two are flip equivalent. Now let's look at this example. We have 1, and on the left we have 2, and on the right we don't have anything, so it's null. Here we have 1, on the left we have null, on the right we have 2. So basically what is happening is that here this tree is flipped, right? So I'm sorry, if we don't flip this, it would have been the same tree as this, right? So these two are also flip equivalent. But can we how can we say that these two are equal, even though they are on the both different sides, right? So let's try to understand this with this example. Let's say these two trees are not flipped. Then what what would we do generally? We will just check whether 1 is equal to 1, and then 2 is equal to 2, and null is equal to null, right? So we will say these two are flip equivalent. So basically on tree 1 and on tree 2, I'm starting at the root node. I'm starting at the root node, and then I'm checking the root nodes whether 1 is equal to 1. They are equal. And then after that I'm going to the left on the tree 1, and I'm going on the left on the tree 2 as well. So when I come here, I'm checking whether 2 is equal to 2 or not. These two are equal. So I'm checking the children of 2. There are no children, right? So it would be null, obviously, and this will also be null. So these two are also equal, right? And then I'll check the right ch children of 2. These two are also null, right? So these two are also equal. So so this subtree is equal, right? So then I'll again go back to the right node. I'll check whether this node is equal to this node. Null is equal to null, right? So we can say that these two are equal, right? We, we can perform the same thing here over here. We'll start at 1. 1 is equal to 1, and we go to the left. We go to the left, and we'll check null is equal to null, and then we go to the right, and we go to the right. 2 is equal to 12. 2. I mean, so these two are also flip equivalent. But the thing is, how can we know that these two are uh, flip equivalent or not? So the only difference between this and this is that here the root is equal, but the thing is when we are going left on the root one, at the same time we're going right. We're not going left on over here. We're going right? And when we are going right over here, we're going left. That is the only difference. If the thing is, so these are our observations, right? So if there is only one node, so this is the thing. If there is only one node, check if both of them are equal or not. Check if both of them are equal or not. If both of them are equal, return true. If not, return false. Otherwise, if we have more than one node, then these are the observations. These are the two cases that can be formed. Oh, I'm sorry. Let's look at this and look at this. Both of these. If the left child of tree 1 is equals to left child of tree 2, left child of tree 2, are these both equal? And at the same time, right child of tree 1, right child of tree 1 is equals to right child of tree 2, right child of tree 2. These two should be equal, or or either this can be the case or this can be the case, right? Let's look at this on the second point. On the second point, left child of tree 1, left child of tree 1 is equals to right child of tree 2, right child of tree 2, and right child of tree 1. Yeah, I'm sorry. This is the right child of tree 1 is equals to left child of tree. This is tree 2. I'm sorry. This is tree 2. So the left child of tree 1 should be equals to right child of tree 2, and right child of tree 1 should be equals to left child of tree 2. If either one of them is true, return true. Means either this can be the case or this can be the case, right? If if it is flipped, then this is the case. If it is not flipped, then this is the case. We're checking. We're checking for not flipped here. We're checking for not flipped here, and we're checking for flipped. In both the cases, if either one of them is true, then we'll return true. Else we'll return false, right? So let's look at the same example. I mean, with this algorithm, let's look at some more examples. Suppose I'm here. We have two cases, right? We have two cases. First one is first one checks whether they are not flipped or not flipped and equal. And the second case is that it thinks that they are flipped and checks whether they are equal or not. So initially I'll be here, right? I'll check whether my root is equals to I'm sorry, the root of tree 1 is equals to root of tree 2 or not. They are equal. So now what I'll do is I'll go to the left and I'll go to the left. I'm checking the first condition. I'm checking the left nodes of both the trees. They are equal, right? So this condition is true, and at the same time I'm checking the right nodes of both the trees. When I'm checking the right nodes of both the trees, then 3 is equals to 3. So the right nodes are also equal. I said either either one of them should be needs to be true, right? So since both of these conditions are true, this became true. So we don't need to check for these, right? Even though it's false, since this is true, we can return true. Let's look at this one. We have first condition and we have second condition. We'll check whether the root is equal to this root or not. They are equal. Now I'll check on the left and I'll check on the left. 2 is 2 equals to 3. It's not, right? So this condition got failed. So I'll go directly to the second condition. What is the second condition? When I'm going left, on the right one I'm going right. I'm checking 2 and these 2 are equal or not. Those two are equal, and at the same time I need to check the right node of the root as well as the left node of the root. 3 and 3. This one is also equal. Since these two are equal, we can return true. Let's look at this big example in order to get a clear idea of what's going on. So let's say this is our tree 1 and let's say this is our tree 2. So in this case, what I'm doing is we have two conditions, 1 and 2. So the first condition is I'll go to the left. Before these two conditions, I'll check whether the node's value is equal to this node's value or not. Since 1 is equal to 1, so this is true. And then I'm checking the first condition, which is going to the left on both the trees. So if I go to the left, it is 2, and if I go to the left, it is 3. So this is not equal. This is not. This condition is false, right? So I cannot go forward with this. So I'll go to the second condition, which is when I'm going left, over here I'll go to the right. Are these two are equal or not? These two are equal, right? So this condition is true. So before just returning true, we need to check whether the subtrees are equal or not. So we are over here on this tree and we are over here on this tree. So for this node, I again do the same. I'll check whether 2 is equal to 2 or not. It is equal. Now I'll check the first condition. Again, the first condition will be new for this, and the second condition is also new for this. I'll go to the left and I'll go to the left. These two are equal, right? So this condition is true. So this subtree is equal, right? Then I'll go to the right, and at the same time I'll go to the right. And again for this node, we again need to do the same thing. I'll check whether the left is equal to left or not. These two are not equal, right? So For this, what I'm going to do is I'll check, since this one is not true. What I'm going to do is I'll check whether the left is equal to right or not. The left is equal to right. This condition is true, and again check the right is equal to left or not. And the second one is also true. So this will return true, and this will return true, and this will return true to this. And since both of them are true, this will return true. And then when we are going on to the right, here we'll be going on to the left, right? I'll check whether 3 is equal to 3. It is, right? And then over here I see that it is on the right side, so I'll go to the left here, I'll go to the right here. These two are equal, and I'll go to the right here, and I'll go to the left here. Since these both are null, these two are equal, so this will also return true, and this will be returning true for this, and this will be returning true for the final function call. So this is the explanation, guys, and let's look at the code. So initially I'm just calling this check if equal function, which will be taking root 1 and root 2, and I'm checking if both are null. If both the given nodes are null, I'll be returning true. And if one of them is null and the other one is not null, then I'm returning false. Suppose it's something like this: 1, 2, and 1, 2. If we have something like this, I'm check if you check the left one and this left one, this has node and this has null, right? Is this node is equal to null? It's not, right? So I'm returning false over here. I'm checking if either both nodes should be null or not. One of them should not be null. So that's why I'm returning false over here. As I said, initially I'll be checking each node's value, whether the value is equal to whether this thing. I'm checking this one with this one, right? If these two are not equal, I'm just returning false. And then, as I said, when the trees are not flipped, what I'm going to do is I'm going to check for the left subtree of root 1 and the left subtree of root 2. At the same time, I'm going to check the right subtree of root 1 and the right subtree of root 2, right? Or if the tree is flipped, I'm going to check the left subtree of root 1 with the right subtree of root 2, and right subtree of root 1 with the left subtree of root 2. As I said, either one of them should return true, right? If 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 the trees are equal without flipping, or if the trees are equal after flipping, we need to return true. That's it. If I run this, it should be working fine. Yes, guys, it's working fine, and thank you for watching the video. And if you find the video helpful, make sure to click on the like and subscribe. Thank you.